Welcome back, kids. We're going to start the naming compounds part of the class. We're going to start figuring out how to name compounds, things like sodium chloride or carbon dioxide. We're going to learn how to come up with the names. But before we can get to the names, we got to figure out how these atoms come together in the first place. So let's today start out with the most important thing. What are ions? How does an ion form? Why do they form? And what happens once they form? And you got to have this. Absolutely got to have your reference table and make sure it's open to the periodic table so that we can discuss atoms and then, of course, how they turn into ions. So all atoms are neutral. You knew that already now for a couple of weeks. Atoms are neutral because they have an equal number of protons and electrons. That's the atomic number. The positive charges equal the negative charges. So number two, all atoms are neutral. They like to be neutral. It's nice. It's nice. All atoms are neutral because the positives equal the negatives. The protons equal the electrons. The protons are in the nucleus. The electrons are flying around outside. And the neutrons are in the nucleus, but the neutrons have no charge. In order for a metal to make a bond with a nonmetal, it has to turn itself from an atom. It has to give up its neutrality. It's got to become an ion, okay? And since the electrons are negative, if you can get rid of some or gain some, you can either become less negative or you become positive, or you can gain some electrons, you become more negative. And once you have atoms that are positive and negative, once you have ions, they're wildly attracted together. So there's a whole system of bonding called ionic bonding, where once you have ions that form, the positive ion and the negative ion are wildly attracted together and they bond really tightly. So next, to start, the noble gases, that's group 18. Group 18, helium, straight down. Helium, neon, argon, krypton, xenon, and radon. Noble gases are perfect, okay? Remember, it's a silly story. Remember, you know, when a noble man marries a woman, can't marry peasant like Cinderella. It's a fairy tale, right? The prince sees this peasant girl just because she's dressed up. They can't marry. The king would never let that happen. They used to believe kings and queens were noble. Noble bonds do not make bonds because they're perfect, right? They really, what they're saying is they have full electron orbitals. They're just perfect the way they are. Not only do they have equal numbers of positive and negative charges, positive protons and negative electrons, but the orbitals are all full. They're perfect. Every other atom on the table outside of group 18, there's room in their outermost orbital to either add some electrons or maybe get rid of some, but the idea is if we could have that perfect outer orbital, if we can only be more noble-like, if we can have that perfect outer orbital, either by losing electrons or gaining electrons, we'd be more perfect, we'd be more noble. And actually, when atoms lose electrons to get the same electron configuration as a noble gas, they can bond. And so there's going to be, by the periodic table, you're going to know how many electrons an atom has to lose, or maybe if it has to gain, to get that perfect outer orbital. And that's something that's really important. Now, giving up the negative electrons will change the atoms into something called an ion. An ion is a charged particle, a charged atom. Metals lose electrons. That's a rule, right? Metals will lose electrons. They can only lose some electrons. And since they have the same number of protons, that doesn't change, but now they have less electrons, they end up net positive. And they could be +1 or +2, or depends on how many electrons they lose. To make a bond, a metal atom has to lose exactly enough electrons to become like a noble gas. And that word's called isoelectric. Isoelectric, having the same electron configuration as a noble gas. They do not become noble gases. They don't even become gases. They just get the same outer orbital, right? It's kind of like, you know, a movie star might have a Ferrari. If I got in a Ferrari, it wouldn't make me a movie star. I just have a car like a Ferrari. Atoms that lose electrons, metals that lose electrons don't become noble. gases. They just become, their outer orbital looks like a noble gas. Like they outside, they're sitting in a Ferrari. They're not making them a movie star, gives them a fancy car. Now, we'll look at this chart, we'll fill it in, and we'll see how things work. Sodium is atom number 11. Put your finger in that box right here. Sodium. Sodium has an electron configuration of 2-8-1, 281, 11 electrons altogether. Now, if it's going to become an ion, it's going to have to lose enough electrons to become the same electron orbital as a noble gas. So let's see what the noble gas electron configurations are. Helium has an electron configuration of just 2. So if sodium were to lose 9 electrons, it would have the same electron configuration as helium. What about neon? Neon is 2-8. Oh, here sodium only has to lose 1 electron. That makes sense. Could sodium become like argon? Argon's 2-8-8. Could metal sodium lose electrons to gain 7? No, that makes no sense at all. As it turns out, sodium is going to lose just 1 electron. By losing 1 electron, instead of being 2-8-1, it's just 2-8. And that's 2 perfectly full orbitals. And that makes the sodium atom no longer neutral because it still has 11 positive protons, but now it's got only 10 negative electrons because one of those electrons gets transferred. We'll talk about where it goes in a little while. And this is how we would write it. We'd still write capital N, little a, Na for sodium, but it has a +1 charge. It's not an atom anymore. It's not neutral. Lithium is our next atom, element number 3. Element number 3 on the periodic table has a 2-1 electron configuration. Lithium's a metal, going to lose electrons. How many electrons does it have to lose to become like a noble gas? Well, it could lose enough electrons so that it has just 2 electrons. So look what it does. Lithium 2-1 loses 1 electron. It ends up with the electron configuration of neon, doesn't become neon. I'm sorry. Helium doesn't become helium. No, it just has the same electron configuration as helium, and it becomes what's called an Li +1 or lithium +1 ion. Now, magnesium's cool. Magnesium is atom number 12. And that one's right over here. Magnesium is atom number 12. 2-8-2. Now, how many electrons do you think magnesium could lose to get the same electron configuration as the noble gas neon? It loses 2 electrons. And if it loses 2 electrons, if it still has 12 positive protons, but now has 10 negative electrons, it ends up with a +2 charge. So when magnesium, the atom, wants to bond, the magnesium has to become an ion. What kind of ion does it become? It becomes a +2 ion. Can't become a +1 ion. Because if magnesium lost 1 electron, it would be 2-8-1, and that's not noble gas. It has to lose enough electrons as a metal to match up with a noble gas electron configuration. Element number 20, Charlie Abuso, calcium, Ca, has a 2-8-8-2 electron configuration. How do you know that? Memorize it. Well, you put your finger in a box. How many electrons does it have to lose to get the same electron configuration as argon? It goes from 2-8-8-2 to 2-8-8. 2-8-8 is like argon. It doesn't become argon. It becomes a calcium ion, +2 ion. It loses 2 electrons. It still has 20 protons, but now it only has 2-8-8 or 18 electrons. So it becomes +20 plus a -18. That's a +2 total charge. Now, aluminum, element number 13, most unfortunate number right here in the middle of the table. Aluminum has a 2-8-3 electron configuration. It has to lose 3 electrons in order to become isoelectric to neon. Now, 3 of these different atoms, when they become ions, become isoelectric to neon. They don't become neon. They don't become gases either. They just have the same electron configuration. It's kind of like 3 different teachers getting into a Ferrari. Doesn't make them movie stars. They just drive like a movie star now. These atoms all are metals. Metals will lose enough electrons to become a positive ion. They lose enough electrons to match up with the noble gas electron configuration. That way you know exactly how many electrons it's going to lose and how positive. It's going to be a positive 1 ion, like sodium and lithium, or it's going to be a positive 2 ion, like magnesium and calcium, or really going to lose 3 electrons, like aluminum. Noble gas are noble. They don't bond. That's what being noble means. They don't bond. They're completely disinterested in you. Metals and nonmetals don't have perfect orbitals, so they kind of combine to get those perfect orbitals. Noble gases are perfect. They're like, hey, get the heck away from me. I don't want to bond with you. I'm perfect the way I am. The reason they don't bond is because they have full electron orbitals, only full electron orbitals. They don't want to borrow your electrons. They don't want to lend you any. They don't want you to give them any. Stay the heck away. Noble gases are perfect, perfect, and they have no interest in bonding. And one of the traits, one of the properties of being noble gas is that you don't make bonds with other elements. When I was in school, they were all inert. Now a couple of them can be forced to do some stuff, but basically they don't make bonds under any kind of normal conditions. Helium and neon and argon are inert. They do not bond. Okay? That's because they have perfect orbitals. Oh, look, I already said this. There's a king and a queen, the noble people. And why? Why don't they bond? Because they're already all full up. They're done. They're perfect. Leave them alone, and they want to be left alone as well. All right, standard issue sodium atom, 281, has 11 protons. 2 plus 8 plus 1 is 11 electrons, and it's neutral. Now, as a metal, it's willing to give up its neutrality in order to become an ion so that it can bond to a nonmetal. How many electrons does sodium need to lose? Now, this is a bit of a review already, but I'm going to knock it into your head to make sure you understand. Let's look at neon. Neon on the periodic table has a 2-8 electron configuration. Sodium is a metal. It's got 11 electrons, 281. How many electrons does it have to lose to become like neon, the closest noble gas? It needs to lose 1 electron. It loses 1 electron, and instead of being 281, it becomes 28. It's going to have the same electron configuration as neon, which is perfect. It's a perfect noble gas, right? It's got 11 protons, and now it's only got 10 electrons because it's 2,8, and that 11 positives and 10 negatives sums up to positive 1. And we're going to write it like this. Na, which is the symbol, but here it's got to say +1, superscript. That symbol means that this is not a sodium atom anymore. It's called a sodium ion. It's a +1 ion. You can have a +1 ion, a +2, a lot of different pluses, a lot of different negatives. If you gain electrons, you become negative. We'll get to that. Sodium +1 ion. The rule is metals are going to lose 1 or 2 or 3 electrons to get the same electron configuration as a noble gas. So their ions are going to be +1, +2, +3, and you have to write the positive sign. Depends if they lose 1 electron, they become +1. If they lose 2 electrons, they become +2. Lose 3 electrons, +3. Now, nonmetals are not metals. They're the opposite. Nonmetals are going to do the opposite. They're going to gain electrons. They're going to gain 1 electron, or they're going to gain 2 electrons, or they're going to gain 3 electrons to become isoelectric to a noble gas, to get that same electron configuration. They're going to end up -1 or -2 or -3. That's going to be their charge. They're going to gain 1 electron and have 1 extra negative. That makes them -1. If they gain 2 electrons, they gain 2 negative charges to become -2. The ions can only form at the same time. Positive ion and negative ion happen at the same time because the metals don't lose their electrons. They get transferred to a nonmetal at the same time. Transfer, not lost. We sometimes say, yeah, a metal loses 2 electrons. It doesn't lose them. They have to go to a nonmetal. You can't just have metal ions that are positive in a jar. You can't have a jar full of aluminum +3 ions. The ions only form when the electrons are literally transferred to a nonmetal. So in this case, look at this. We got sodium. It gives up or transfers its outermost electron to a chlorine. Sodium is 281, but this is a simple picture. That outer electron goes over there to the chlorine, which is 287. You only see the outer orbitals here. The chlorine now has 8 electrons in its outermost orbital. That's perfect, but it's an extra electron. That makes the chlorine negative. See how it says Cl negative inside that little nucleus? The nucleus is not negative, but it's the atom. This is a cartoon. And the sodium, which used to be 281, now becomes 28. That's it, 28, 2 full orbitals, and the outer orbital is now empty. That's what they're seeing. And it's a positive one and negative one, and they go together like a hand in a glove. Positive one, negative one matches perfect, and it's a really, really strong bond. So when a metal and a nonmetal bond, like sodium and chlorine, and makes something you know is called sodium chloride, it's all about the electron transfer. There has to be a balance of charge. And in this case, a positive 1 sodium ion and a negative 1 chlorine ion come together and make a neutral compound. Positive ion plus a negative ion, positive 1, negative 1 sums to 0. The compound is still neutral, but it's made up of positive and negative ions. Now, ions don't have to form. I got a can of aluminum here. See this? My berry, dragonberry and fruit seltzer, aluminum can, aluminum atoms. They don't turn into ions. They're very happy. Leave them alone. They're atoms. But if the aluminum is going to bond, it has to get that perfect outer orbital. It's got to become isoelectric to noble gas. It doesn't become a noble gas. It becomes isoelectric. It has the same outer orbital. So if aluminum is going to bond to oxygen in the air, or aluminum is going to bond to chlorine, if we happen to have some chlorine gas, which would be very dangerous, I'd be dead. It would have to become an ion. It would give up its electrons and transfer them to the nonmetal, and then we'd have positive ions and negative ions, and they'd be snuggly, right? Positive and negative. Now, the noble gases are like models for us. How many electrons do metals lose? They only lose enough to become like the noble gas. How many electrons do the nonmetals gain in order to become bonded to the metals? Well, they gain enough electrons till they become isoelectric to a noble gas. We look to the noble gases to see how many electrons is perfect. The metal ions form when they get perfect orbitals, and the nonmetal ions form when they gain enough electrons to be perfect. And when a metal and a nonmetal come together, like this sodium and chlorine diagram here, it's got a lot more electrons now, but see, the sodium is 2,8 and the chlorine is 2,8,8. That's the ion electron configuration. They make what's called an ionic bond, that yellow business there with the plus and minus. The sodium side is more positive and the chlorine side is more negative, and they become wildly attracted. It's like love. Love, positive and negative ionic charges. Okay, we're gonna go through this quick as we can, all right? This is all in the notes. You can come back to this. It's in the slideshow too. Lithium's the first example. What does it say? The atoms are in red. Electron configuration right on a periodic table. 2-1. When it becomes an ion, it's a metal. It's going to lose electrons. It's going to lose 1 electron, become an ionic configuration of just 2. The symbol is going to be Li plus 1 and becomes a positive 1 ion. And in parentheses, what does that He mean? He means, what noble gas does the lithium positive 1 ion have an electron configuration like? Which noble gas is it isoelectric to? Helium. How do you know that? Look, helium has an electron configuration of just 2, just like the lithium cation. Lithium ions do not become noble gases. It doesn't become helium. It has the same electron configuration as helium. This next one, sodium, we've done this one already too. 281. It's a metal. It's going to lose electrons. How many electrons does it lose? It loses enough until it gets to be like a noble gas, like neon. So it's going to lose 1 electron again. It's going to become 2-8. It used to be 281 when it was an atom, but when it becomes a positive ion, it loses a negative electron. How many? 1. So we write Na plus 1. And what noble gas is a 2-8 electron configuration? Look, it's neon. 2-8. 2-8. Potassium is element number 19. Put your finger in the box. K for potassium. When you write a letter like that, that means the pitcher struck out the batter. A K. K stands for potassium. It's got 19 electrons, 2-8-8-1. It's a metal. It's going to lose electrons to become isoelectric to a noble gas. How many electrons does it lose? Bada bing, just 1. 2-8-8. It loses 1 electron. the potassium ion becomes a K+1. What noble gas has a 288 electron configuration? Just put your finger in the box. There's only choice is 6. It's the third one. It doesn't become argon. It's still a metal ion. Argon's a noble gas. But potassium +1 ion now has that perfect orbital system, just like argon. Rubidium is an element you probably never even heard of, number 37. It's down here, Rb. Rb, let me stop you for a second here. Here's lithium, here's sodium, here's potassium. Oh, look, snap, here's rubidium. They're all in what? They're all in group 1. What does lithium got? It only has 1 electron in the outer orbital. What does sodium got? 1 electron in the outer orbital. What about potassium? 1 electron in the outer orbital. What about rubidium? What do you think? When you only have 1 electron in the outermost orbital, how many electrons are you going to lose when you become an ion? You're going to lose 1. Look at this. It becomes 2,8,18,8. It loses that last orbital electron. It becomes a rubidium +1 ion. What noble gas is 2,8,18,8? I don't know. Put your finger in a box. Krypton. Now, here's a little trick. On your periodic table, see where it says number 1? Right there, above. Group 1. Right there in a little circle. Let me find the pen. I'm going to put right there a little +1, because everything in group 1, lithium, sodium, potassium, rubidium, cesium, and even francium, they all make only +1 ions. That's why they're all in the same group together. They all bond the same way. Group 1 metals are similar. Atoms in the columns, in the groups, are similar. Okay, let's see what we got coming up. B. Be all you can be. I know you don't know where that one is. It's right here. It's in group 2. Beryllium, underneath it is magnesium, and then calcium, and then strontium. Look, we got B, E, M, G, and Ca, 3 metals in a row. Beryllium has a 2-2 electron configuration. How do you know that? Just put your finger in the box. It's right there. Don't be lazy. Go get this. You're going to need this. How many electrons does it have to lose, beryllium, to become isoelectric to noble gas? What do you think? It loses 2. It goes from 2,2 to just 2. So it becomes isoelectric to helium. Now, beryllium is atomic number 4. It's got 4 protons and 4 electrons, but if it loses 2 electrons, we got 4 positives and 2 negatives. It becomes a +2 charged ion. Some atoms, like lithium to rubidium, all the way down to francium there, they all lose 1 electron, they become +1 ions. If you lose 2 electrons, they're negative. Each one of them is -1. So if you lose 2 of them, you end up net +2. Magnesium, 282. See it? How many electrons you think it's going to lose? You think? It's going to lose 2 more. 2,8. That makes it isoelectric to neon. You know what? Sodium becomes isoelectric to neon too. Sodium and magnesium, they're different. Sodium loses 1 electron. Magnesium has to lose 2 electrons, a +1 ion, +1. Okay. They both become isoelectric to neon. They're both modeling themselves to bond with the perfect orbital. They don't become neon. They just get the same electron configuration. Underneath magnesium is Charlie Arbuso, number 20. I mean calcium, Ca. 2,882. Come on, think. How many electrons are going to lose before it looks like argon? 2. Where's my hand? All right. It doesn't become argon. It becomes calcium +2 ion. And then finally, aluminum. We did this one before. Aluminum. 2,883 loses 3 electrons. So look, we got +1 ions, +2 ions, and +3. You know what I'm going to do now? Right above group 2, I'm going to put a +2. Everything in group 2 that goes up and down, they all have 2 electrons in the outermost orbital. They're only going to make +2 ions. And look what I'm going to do over here. Where do you see this? For aluminum, aluminum is special. I don't know where the heck this is. Look at that. I put a little +3 going right into the aluminum box. Aluminum's by itself. Group 1, group 2, and aluminum. +1 ions, +2 ions, and aluminum is a +3 ion. I like this picture, right? Why did I pick this picture? Because it's stupid, right? Look at this dumb cat. Dogs are better. Look at the pictures these kind of animals take. Metals lose electrons. They become positive ions. And a positive ion happens to be called a cation. It's kind of a funny name. There's a reason for it. We're not going to talk about it. Cations. Metals can become +1 cations, +2 cations, +3 cations. We don't say positive. Just say cation. It means positive. They don't lose protons and they don't lose neutrons. They transfer. They don't even lose their electrons. They give them up. They get sent over somewhere else. They give up their neutrality and become positive so that they can bond. They lose enough electrons to become isoelectric to a noble gas. They don't become the noble gas. And then, because they're positive, if they could find some negative particles to be attracted to, they'd be wildly attracted to the negative particles. Here we go. I'm having a hard time with this here. There we go. Look at that. There's our heart. What we need is some positive ions and some negative ions come together and bond tight, like Charlie and Janet. Me and my wife are ionically bonded, the strongest bond in chemistry. What do we call a negative ion? Look at this cute little puppy here. I love cute little puppies. They call dog ions. No, they're not. That's just a stupid joke. It is a cute picture, though. The non-metal, they gain electrons, and they are called anions, like negative, anti, anions, anions, right? We got cations that are positive, but cats are not really positive. Cations are. And then we get the negative ions. Look at that cute little dog. Everybody wants a dog like that for a little, like an hour. Then he's got to go bathroom. He makes a mess, but he's cute for a while, right? Look at that. Look at this other animal. Ooh, look at this. Who wants this animal? Right? You don't want that. You want this one. Cations are positive, anions are negative. Now, metals lose electrons. They form into positive cations. At the same time, non-metals gain electrons. They come from the metals, and they form into negative ions or anions. Now, the cations and anions bond together with what I wrote down here, mad strength. Ionic bonds are the strongest bonds in chemistry, positive and negative. And they have to bond balanced so that there's a balance of positive, negative. The compound that forms has to be neutral. That means the positives and the negatives combine to net zero. So we got to keep track of what is the charge of the positive ion, what is the charge of the negative ion, and we got to get them to match up. So we're going to go through this chart really quick too. These are nonmetals. There's a whole bunch of nonmetals here. Fluorine's our first example. Fluorine is over here in group 17. Has a 2-7 electron configuration, but it's a nonmetal. Nonmetals gain electrons to form an anion. How many electrons would it have to gain? Just one. If it gets one more electron, instead of being 2, I'm almost filled with 7, it becomes 2, I am filled with 8. And we would write that symbol F-1, not an atom anymore, not neutral. It's a negative charge because nonmetals gain negative electrons and it becomes isoelectric to neon. It does not become neon. It gets the same outer orbital as neon. Chlorine is right underneath fluorine, right under, look. We got, where are we? Look at this crazy thing. Here we got the F. Then we got the Cl. Look, then we got the Br and the I. They're all coming in a row. Chlorine is 287. It's a nonmetal. It's got to gain electrons. How many electrons does it have to gain to be isoelectric to a noble gas? Just one. It becomes isoelectric to argon. It does not become argon. It's chlorine -1 ion, an anion. Chlorine anion. Bromine. And iodine. Look at them both. They both end with they both end with 7. They all end with 7. They're all going to become -1 ions. And you know what I'm going to do? I'm going to get my little pen out. And right above group 17, I'm going to write -1. You know why? As a reminder that everything in group 17 only makes a -1 ion. This way I got a little remembering. I can remember it. It's written right there. I don't have to think too much. Thinking hurts. This is like a reminder. All the atoms in group 17 end with 7 electrons. They're all nonmetals. They all have to gain 1 electron to become -1 ions in order to bond. Next, we're going to look at O and S, oxygen and sulfur. Group 16, oxygen and sulfur. Now, there's more. There's selenium and tellurium, but we're not going to talk about them. We're just going to do some examples. Both of these, oxygen 2-6 and sulfur 2-8-6, they both end with 6. How many electrons you need to be isoelectric to a noble gas? Every noble gas, except for helium, it's too small. How many electrons in the outermost orbital? 8. So how do we make oxygen 2- add 2 electrons, gain 2 electrons, and what happens? You become 2-8, but you become a -2 anion. It still has a total of 8 protons, but now it's got 2 + 8, it's got 10 electrons. So 8 pluses and 10 negatives is -2 charge. So an oxygen anion is O-2, and it has the same noble gas configuration as neon, does not become neon. Sulfur, 2-8-8, it gains 2 electrons. Everything in that group does the same thing. They all have 6 electrons in the outermost orbital. Look what I'm going to do now. I'm going to put a -2 here. Look what I got going on. I got all these reminders on my periodic table. Can you see this? Look at that. Group 17 will make -1. Group 16 will make -2. What do you think might happen with nitrogen and phosphorus? Come on, take a wild guess. Wild guess, quick. Nitrogen has a total of 7 electrons, 2-5. It's a nonmetal. It's got to gain enough electrons to become isoelectric to noble gas. How many electrons does it need to gain in order to become just like neon, 2-8? Of course, 3. And if it gains 3 electrons and a negative, it becomes an N-3 ion. N-3 anion. And phosphorus, right underneath it, 2-8-5, how is it going to become isoelectric to argon? It's got to gain 3 electrons. Look at that. And look what I'm going to do. Everything in group 16 has a -2, and everything in group 15 is -3. And just for fun, over the noble gases, I'm going to write no ions at all. See what I got on the top of helium? No ions. So on the metal side, we got +1 for group 1, +2 for group 2. Then we got aluminum by itself that makes a +3. And then up here, we got no ions in noble gases, -1s, -2s, and -3s. This is a good start. We're going to deal with the middle of the table another day, tomorrow maybe. Look at this beautiful little diagram at the bottom. Isn't that a crazy little cartoon? How many electrons are showing? What atom is it? Got to only be 1 atom with 3 electrons. Okay, bonding requires a balance of positive and negative charges. The positives and the negatives. The positive cations, the negative anions come together and they have to balance. In order to make sodium chloride, the sodium is a +1 ion. The chlorine is a -1 ion. +1, -1. The sodium transfers 1 electron to the chlorine. The +1, the -1 become wildly attracted and they bond into, in a 1-to-1 ratio, sodium chloride. Now, magnesium oxide, you saw this in the lab. We burned the magnesium and I showed you that white crystal powder that it formed, magnesium oxide. Magnesium makes a +2 ion. Oxygen has to gain 2 electrons. So 1 magnesium can lose or transfer 2 electrons and the oxygen picks them up. So we get a +2 and a -2. That's also going to be in a 1-to-1 ratio. So we can make a compound called magnesium oxide, MgO, in a 1-to-1 ratio. Right? That's how the formula, and has to be 1-to-1 because a +2 is balanced by a -2 in a 1-to-1 ratio. If it wasn't a 1-to-1 ratio, there'd be too many positives or too many negatives, and that's not cool. Got to be neutral. That's all. That's all. Metals lose electrons, they become positive cations. Non-metals gain electrons, they become negative anions. And then when they come together, we get to this next class. How do you name a simple compound? This is a real big chunk of sodium chloride, but I'm not going to tell you about it, right? You got to come back. This is the slide, but we're not going to talk about it. NaCl, we call it sodium chloride. The other stuff was called magnesium oxide, made with magnesium metal ions, so magnesium cations, and oxygen anions. We call it magnesium oxygen. No, we don't call it magnesium oxygen, magnesium oxide. And when this stuff forms, sodium and chlorine, we don't call it sodium chlorine. You know it's not that. Sodium chloride. And you would never call it chlorine sodiumide. That would be dumb, right? Could you imagine you're in a lunchroom? Hey, I just got some French fries. Well, we'd have to imagine you're in a lunchroom and there's no pandemic. But imagine in a lunchroom, you're having French fries. Yo, pass me the chlorine sodiumide. Somebody will poke you in the eye for that. Like, what are you kidding? Don't you know anything? Don't you take chemistry with Charlie Abuso? You can't say the name of the anion first. You say the name of the metal cation first. That's a rule. Sodium chloride, magnesium oxide. And you don't say INE, sodium chlorine, or you don't say oxygen, you don't say magnesium oxygen. You sound silly. Say it right. Magnesium oxide, sodium chloride, IDE, ends in "ide," rhymes with tide, rhymes with lied. Didn't spell it the same. I won't lie. I'm done. We talk too much. Have a swell day. Thanks for watching.